This is lesson 1-6, variables and expressions. In the mini-lab, a pattern of squares is shown. Draw the next three figures in the pattern. Done that down here. It says find the number of squares in each figure and record your data in a table like the one shown below. The first three are completed for you. So this is figure 4, and we have 4 vertical and 3 horizontal. Taking into account the overlap, we have 6 squares. In our 5th figure, we have 7 squares. In our 8th figure, or our 6th figure, we have 8 squares. Without drawing the figure, determine how many squares would be in the 10th figure. Well, if we continue the pattern, we have 7, which gives us, or figure number 7 gives us 9 squares. Figure number 8 gives us 10 squares. Figure number 9 gives us 11 squares. And figure number 10 gives us 12 squares. It says find a relationship between the figure and the number of squares. If you look vertically like this, it's reasonably easy to see that the number of squares is 2 more than the number of the figure. It says in the mini-lab you found that the number of squares in the figure is 2 more than the figure number. You can use a placeholder or variable to represent the number. A variable is a symbol that represents an unknown quantity. So the figure number here is represented by the n, and we add 2 to each figure number to come up with the number of squares in that figure. The branch of mathematics that involves expressions with variables is called algebra. The expression n plus 2 is called an algebraic expression because it contains variables, numbers, and at least one operation. In a previous lesson, we studied numerical expressions that might look something like this. Notice we have only numbers and operations, no variables present in a numerical expression. Evaluate n plus 3 if n equals 4. What we do in this case is we take the algebraic expression n plus 3, replace the variable with the number, changing from algebraic to numerical, and then we simply add the two numbers together. The value of the expression n plus 3 when n equals 4 is 7. It says evaluate each expression, which means find the value of each expression if c equals 8 and d equals 5. So in our first example, c minus 3, c being 8, we would replace the c with an 8. 8 minus 3, the value of that expression then when c equals 8 is 5. In example B, 15 minus c. In this case, again, 8, or c is 8, so 15 minus 8 is 7. The value of that expression is 7. In example C, c plus d, we have c equals 8, d equals 5. The value of that algebraic expression then when c equals 8 and d equals 5 is 13. In algebra, the multiplication sign is often omitted. Notice that in these 3 examples, there is no raised dot, there is no x to indicate multiplication. The numerical factor of a multiplication expression that contains a variable is called a coefficient. So 6 is the coefficient of this algebraic expression, 9 is the coefficient of that expression. In our third expression, we have no numerical coefficient other than the understood 1. In our first example, it says evaluate 8w minus 2v if w equals 5 and v equals 3, so we replace the w with a 5 and the v with the 3. 8 times 5 is 40, 2 times 3 is 6, 40 minus 6 is 34. In example 3, 4y squared plus 2y if y equals 3. We replace the y with the 3, changing that to 3 squared rather than y squared. We evaluate the exponential form number. 3 squared is 9. 9 times 4 is 36. Plus 2 is 38. In our 3 examples, D, it says 9a minus 6b. 9a minus 6b. If a equals 4, this becomes 9 times 4. And if b is 3, this is 6 times 3. We have 36 minus 18 makes the value of that expression 18. In our second example, notice here it says that the fraction bar is also a grouping symbol. It says evaluate the expression in the numerator and first and then the denominator separately before dividing. So we're going to do that. A times b divided by 2 means 4 times 3 divided by 2, which is 12 divided by 2, which is 6. In our third example, 2a squared plus 5. A again is 4, so it's 2 times 4 squared plus 5. 4 squared is 16, so 2 times 16 plus 5, 32 plus 5. The value of that expression is 37. Use the formula at the left to find Latrina's minimum training heart rate if she is 15 years old. In the formula, the variable A represents the heart rate of the individual. So in this case, we replace the A with a 15 because Latrina is 15 years old. We do the subtraction first because it's in parentheses. 220 minus 15 is 205. 3 times 205 is 615. See that here? 615 divided by 5 is 123. Latrina's minimum training heart rate is 123 beats a minute. To find the area of a triangle, in the check your progress example, you can use the formula B times h divided by 2, where h is the height and b is the base. What is the area in square inches of a triangle with a height of 6 inches and a base of 8 inches? So b times h divided by 2 becomes, the base is 8. The height is 6 divided by 2 becomes 48 divided by 2, which is 24 square inches. Remembering that area is always in square inches. Evaluate each expression. If a equals 3 and b equals 5, we'll do the first couple here and then we'll do the odds or the evens when we get down to the end of the assignment. A plus 7. If a is 3, this becomes 3 plus 7. The value of this expression when a equals 3 is 10. Second example, 8 minus b. If b equals 5, this becomes 8 minus 5, which is 3. In our third example, b minus a becomes 5 minus 3, which is 2. Number 4, the standard formula for finding your maximum heart rate is 220 minus a, where a represents a person's age in years. What is your maximum heart rate? Well, if the average 6th grader is 12 years old, you would replace the a with a 12. You would then subtract and you would get 208. That would be your maximum heart rate. In the third part here, we're going to do the even numbers. We're going to do 6, 8, 10, and 12. So 6 is 7m minus 2n. That becomes 7 times 2 minus 2 times 6. 14 minus 12 is 2. Example 8 is n squared plus 5. N is 6. So 6 squared plus 5 is 36 plus 5, which is 41. Number 10. 3p squared minus n. If p is 4, this becomes 3 times 4 squared minus n, which is 6. 3 times 16 minus 6 becomes 48 minus 6, which is 42. Example 12, 3n divided by 9. Again, n equals 6, so it's 3 times 6 divided by 9, which is 18 divided by 9, which is 2. Here are the answers if you want to go back and check yours to see if you're correct. You could go back and work the odd numbered problems if you need a little more practice. Here's the vocabulary for this lesson. You're responsible for knowing these. You'll be evaluated on them at a later date in the chapter, so memorize them. At this point, you should quit the movie, go back to the Scott Highlands homepage, go to the Moodle login link, type in your username, which is your student number, and your password, which is the first 6 letters of your last name, plus your birth date. Good luck.